So hello everyone, my name is Akshay and welcome back to this GFG POTD of day 148. तो कल मैं यार वीडियो नहीं बना पाया. टुमारो आई वाज वेरी टायर्ड एज यू से. मैं बहुत ही थक गया था यार, ये 5 दिन ऑफिस एंड एवरीथिंग करके जिम विम जाके. तो इट वाज लाइक वेरी टायरिंग यार, तो मैं बना नहीं पाया. तो फर्स्ट ऑफ ऑल सॉरी फॉर दैट डिले. और अगर आपने क्वेश्चन खुद से कर लिया यार और खुद से नहीं भी कर पाया, विच आई होप कि नहीं हुआ होगा क्योंकि मेरे को भी बहुत समय लगा. इंस्टेड मैंने बहुत सारे हेल्प भी लिए, है ना. ये क्वेश्चन है ही ऐसा. तो कोई बात नहीं यार. अपने अगर आपने दूसरे सोर्सेज से हेल्प लेके अपना क्वेश्चन कर लिया हो तो दैट इज़ वेरी गुड. बट स्टिल मेरे को स्ट्रीक मेंटेन करनी है, मेरे को सारे क्वेश्चन समझाने हैं, तो आई एम टेकिंग दिस वीडियो. सो द क्वेश्चन नेम इज मीडियन ऑफ एरेज. हार्ड करिए क्वेश्चन है बट ऑब्वियस. तो क्वेश्चन क्या कह रहा है यार कि हमारे पास एक एरे है. वी हैव एन एरे ऑफ एन इंटीजर्स एंड इंटीजर एम. द टास्क इज टू काउंट द नंबर ऑफ सब एरेज हैज मीडियम इक्वल्स टू एम, right? और median क्या होता है यार, if the array is sorted, if it is given a sorted array is given, then the middle element for the odd element, the middle element will be the answer. And if there are two middle elements, then from the left of the two middle numbers will be your answer, right? तो इसका देखो, अब ये सब array क्वेश्चन है, तो wherever the sub array comes, then the brute force is that use the n square nested for loop to form all the sub arrays and do what the question says, right? पहली अप्रोच अपनी वही होने वाली है. मैंने ऑलरेडी आई हैव रिटन एवरीथिंग which I need to solve this question, so that ये question I can make this video in the minimum time. So the method one will be brute force technique, that you form all the sub arrays. We use two for loop for do that, and we do as the question says, right? So the question says that after for each and every sub array we need to find the median. To find the median according to this note here, to find a median we need to sort an array, right? So sorting an array will again take n log n time, and then we can just find the middle element that will take O of one time. Total time complexity for this approach will be n square into n log n, that is n cube log n, right? And the constraint for n is given as 10 power 5. So if we place 10 power 5 here at the point of uh, n, it would definitely go beyond 10 power 8, right? So that is why this approach will give you TLE. But still, let us code this approach and let us verify the TLE comes out. I have already coded this approach. Let me just write that thing and we will verify. Till then, you also try to write the code by yourself. So that's the code here. Let us hit the submit button. So you can clearly see that this is the nested for loop at line number 35 and line number 38. We are considering all these sub arrays, and then for all the sub arrays we are storing it in array list, sorting it, and we are considering if it is even, then we are taking the size by 2 minus 1, and if it is not even, that is odd, then we are just pinpointing out the middle element, right? So you can see only 335 cases are submitted, because for those 3 to 5 cases the time complexity would have been less than 10 power 8. That is why it's happening, right? So the expected time complexity is given as O of n. तो ये अगर आप ये क्वेश्चन नहीं कर सकते यार, अब ठीक है, अगर आपने कर लिया तो इट्स वेल एंड गुड, वेरी गुड. लेकिन मैं उम्मीद कर रहा हूँ कि ये क्वेश्चन नहीं हुआ होगा, ठीक है. और ये क्वेश्चन ऐसा है यार कि मे बी इफ यू हैव फॉलोड सम रिसोर्सेज आफ्टर सीइंग आल्सो you would have not able to solve the question, right? Because ये है ही ऐसा यार. So some questions in a time comes like this. So what is the intuition behind it is, let us read the points I have mentioned here. So the method 2, let's say we have an array 1 2 3 4 5, right? I can say this sorted array the median is 3, right? So इस पॉइंट से मैं ये भी बोल सकता हूँ यार कि number of elements which is greater than this 3, which is actually the median, we can count it. It is 3 4 and 5. So that is the number of elements greater than equals to 3 is actually 3, and this count is nothing but it is saying that more than half of the elements will be greater than this median. बड़ी obviously बात है यार, अगर आप median, if you are pinpointing the middle element of a median, then the right rest half will be greater than that median, right? But obviously because it is sorted. Okay, so what is the logic here is that, so if I say that the more than half of the elements in array, let's say if I say that it is greater than m, right? Now I'm just if you understand this statement, then I'm just doing the vice versa thing now. So if more than half of the elements in the array, if it is greater than m, that is the median given, that means the median will also be greater than m, greater than equals to m, right? Right or not? You can clearly verify this from this above statement, है ना. तो यही intuition हम करने वाले हैं. We do not have the code to solve, to code for exactly how many number of sub arrays will be equals to m, but we can do for how many greater than equals to m. How we can do that? How we can solve for the all the number of sub arrays which have the median greater than equals to m, right? So how we can do that? So let's say we have this array elements 2 1 3 5 4, and for m equals to 2. So the first step will be that we are replacing this our array element with 1 if it is greater than equals to m. And if it is not, then we are replacing it -1, right? So we have done that thing, and then I'm saying that now, considering this array, this of 1 and -1, if there is a sub array with some 0, then that means for that particular sub array the median will be 2. You can verify it as well. Respectively key, for that particular sub array 2 is present in that sub array, right? Because you can clearly see that this and this 2 will also be producing sub arrays some with 0, but for 1 and 3 the median will be 1. You can clearly see that, while I'm saying it should be 2. So it should be 2 if and only if 2 is a part of that particular sub array which has sum you are choosing, right? So if I choose this thing, you can clearly see that the sum is 0, right? And we can see that, right? ठीक है यार. So sub array with sum greater than 0 will have, this implies that the median will be greater than equals to 2, right? So you can verify with all the other examples, let's say 2, 1 and 3, right? And you can see the sum for 2, 1 and 3, the weightage are 1, -1 and 1. If you sum this thing, it will be sum equals to 1 and m is equals to. So if you find the median of this sub array, you have to sort it 1, 2 and 3 and you will get 2, right? And you will return 2 as median. So this point is proven, right? This one and okay, this one and this one, right? So now what we have to do is that we will maintain. So I'll know, let's store a variable x which is responsible for all the sub arrays which is having greater than equals to m median, right? And let's store a y, a variable which is responsible for all the medians greater than equals to m plus 1. So if you do x minus I, then they will be getting the sub array, all the number of sub array with median m, right? So let us see how we can do that. So this question is more on an understanding part here, not more on the solving part, right? I've already made the dry run here, and then you will see how the things are happening. If you're able to, not able to, if you understand this dry run, then also I think that you need to run one or more test cases by yourself using this pseudo code here, and then only I guess that you'll be able to understand how the question is getting through. So don't be frustrated here. This question is actually a bit lengthy. Okay, so we have these elements as 2, 1, 3, 5, 4. We have the first thing we are doing is that we are replacing with the elements with the weightage. We are solving for m equals to 2, right? So what is this x? Now we are maintaining one more array, that is 1, 0, 2, 4, 5. What this is representing is that this one at this stage, it is saying that the number of sub array with sum greater than 0, including this element and till the back, this element to the leftmost, right? So the number of sub array with sum greater than 0, including this element and the leftmost, will be equals to 1. How we can say that? So if you're considering at this point, then only the sub array you will form is just 1, right? And if you're at this point, the number of sub arrays will be forming, you will form 1 and then you will form 2, 1. So that's what I have written, 1 and 2, 1. If you're at this point, then the number of sub arrays formed with the help of the leftmost, all the left elements from this point will be 3, then 3, 1, right? And then 2, 1, 3. Similarly for 5, it will be 3, 5, 1, 3, 5 and 2, 1, 3, 5, right? That's what I have written. And now I've calculated the sum for each and every sub array, right? So you can see for this one, for this just element 1, the sum is 1, right? So that's what I've written 1. This is the second row is representing the sum, right? Okay. So now I'm counting the number of sub arrays which has the sum greater than equals to 0, right? 1 is definitely, so I'm maintaining the count. Similarly here, I maintain the sum -1 and 0. If it is number of sub arrays having sum greater than 0, here is no one. So so this 0 is updated and 0 is pointed here. Similarly, this 2 is copied here, and this 4 is copied here, and this 5 is copied here, right? See this, how the sum is getting calculated. I'll show you for just one case. So let's say for 5, you are at this point, right? You are just considering the sub array 5. So what's the sum? Just 1. So I have mentioned 1. Similarly for 3, 5, the sum weightage is 1 and 1. So I have mentioned 2. Similarly 1, 3, 5, it will be 1 plus 1, 2 minus 1, that is 1, and then 1 plus 1 again 2 for this 2, 3, 1, 5. And all the sub arrays which have this sum greater than equals to 0. This is the sub array. And all the sub array sum which is greater than 0, I maintain the count, that is 4, right? So how I am doing this is, so yeah, so if I do this, right, so this will be my total sub arrays 5 plus 4 plus 2 plus 1, that is 12, which has the median greater than equals to 2, right? And if I do the same thing, if I do the exact same thing with for m equals to 3, then you will get here at 5 plus 3, 3 plus 8 plus 1, 9, 9. So there are 9 possible subarrays which have median greater than equals to 3. So if I subtract it, then it will give 12 minus 9, that is 3, which was our answer, right? So that's the pseudocode I have mentioned here. Okay. So ये जो the dry run which I just showed you, it's very simple if you look at those numbers, right? But when you try to code this, approach, then it is even more complex, है ना? Even more नहीं, बहुत complex. तो ड्राई रन देखना, इट्स वेरी सिंपल यार. ये नंबर्स मैं जैसे को समझाया, आई डोंट थिंक कि आपको उसमें कोई प्रॉब्लम हुआ होगा. आई डोंट थिंक दैट यू बी फेसिंग एनी प्रॉब्लम just seeing this dry run, right? Just seeing the numbers, how it is coming here. But to try to do the same thing via code is a bit lengthy and a bit more challenging to code yourself, right? Okay, so the second row was pointing to sum, right? And the third row was pointing to, let's say, variable x. So that's what I have maintained, two variables, sum and x. And now I'm using a map as well, right? So initially, when I was this point, then we have, so what this map is indicating is, let me tell you that. So since it is sure that for median, let's say 2, right? So 2 will be definitely present in our array. So this map is just saying that 0 to 1, it is just saying that the number of sub arrays with sum 0 is 1 as of now. I can say that, right? Because the median itself will be there in your array elements, right? So for that median, you can just consider that particular one element as a sub array, right? So suppose for 2, I can just say that the 2 is one sub array, right? And right, yeah. So what I'm saying that, yeah, the number of sub array with the sum 0 is 1, right? Then we have maintained sum and x variable, which is initially pointing to 0 and 0. And for the elements which is greater than equals to 1, we are doing these things, that is x plus equals to mp of sum. Mp is nothing but the map. And then we are doing sum plus plus. And these steps is constant, that whenever we have taken that particular sum, we need to update in the map, right? Why? Because I'll tell you. Let's just do the first two iteration, then I'll tell you what's the how the map is taking care of all things, right? So the first of all, the sum is 0, x is 0, and we are doing x is x plus mp of sum. So sum is nothing but initially it's 0. So 0. So map is containing these elements from 0 to 1, right? So you can see now, and at last, so the x is updated to 0 plus 1, that is 1. So now the x is updated from 0 to 1, that's what I have shown here, right? And then map of sum plus plus. So this is just saying that you have encountered a current sum that is 1, right? So update this in a map that now you have a sub array with sum 1 and the number of sub arrays itself is 1, right? So now let me tell you what exactly the map is going to do here. So let's say suppose we are at this point, right? And we can clearly see that the number of, we are at this point, right? And you can clearly see that the number of sub arrays, right, with sum greater than equal, that the number of sub arrays which are, you are at this point, right? So you can clearly see that the number of sub arrays with sum 0 is only 1. With sum 0 is 2. How you can say that? That you can consider these two elements 2 and 1, and then you can consider 1 and 3, right? And that's what you can see in the map. It is updated for 0. So sum 0, the number of possible sub arrays is 2, and it's saying that for the sum 1, the number of possible sub arrays is 2 again. So you can, for the sum 1, you can take this element solely, and then you can take this element solo, right? So that is how it is running. I have already showed you all the dry run with this particular example. Try to dry run this case in yourself with pen and paper on your copy, and you will definitely understand. I already showed you that at a particular iteration what the map is showing, right? And I already verified it. You can verify it yourself. So at 5 it is just saying, the map is saying from 0 to, so it's saying that for all the elements that is from 2 to 5, the map is saying that the number of possible subarrays with sum 0 is 2, with sum 1 is 2, and with sum 2 it's 1. And that is how it is getting used in our next previous iterations in O of 1, so that we do not have to form all this possible subarrays which I showed you in the dry run, and it is taken care of, right? तो ये है यार एक complex question. I'm again saying it. Try to dry run this same thing yourself, and you will definitely get it. So when you do that thing, now let's use the pseudocode to code our editor to code the solution, and let us see, right? So meanwhile, you can pause this video and try this yourself using pen and paper and try to code it yourself. Meanwhile, I'll do the coding and I'll show you, right? Okay, so that's how the code looks like, right? We have make a function that is long count. Yes, and then we have made the variables answer, x, and sum. We have made a map, an unordered map, and at first we are putting 0, comma 1, right? You know why we did that? Because we are sure that the median itself is present in our array, right? So we can just take that element as a sub array, and we can say that you have this thing in your element, and one sub array is already present. And I already said the sum array will have the sum 0 if the element uh, the sub array will have the sum 0 if the median is equals to the given number. That's what we are putting map.put 0, comma 1, and then we have a for loop. We are just making two if and else statement. If it is greater than equals to m, then the weightage of sum is plus 1, right? So that's why we're doing sum plus plus. And if it is less than m, then the weightage of sum is minus 1. So that's what we are doing, sum minus minus. Instead, you would have made a new array also. We would have updated the weightage value as 1 and minus 1. You have done that in that case as well. But let us not just use a variable, and let us just we did the smart work and we optimize the space. Okay, so that's the exact thing I showed you in my what is say in my pseudo code, right? और ये आपको तभी समझ में आएगा यार, मैं कितना भी समझा लूँ आप नहीं समझ पाओगे, ठीक है? जब तक आप ये लाइन खुद से ड्राई रन नहीं करोगे ना, ये नहीं समझ आएगा, ठीक है? एंड आई हैव ऑलरेडी showed you enough evidences कि ये काम कैसे कर रहा है ना? At which point what is the importance of map, right? और without map भी ये solution कैसे काम कर रहा है मैंने आपको ये बताया, considering all the sub arrays at each point. That is how it is handling the cases. But to code this approach, we do not have to form all the sub arrays again and again. That is why the map is there to take care of it, right? So until and unless you do not do this line dry run yourself, I don't think you will get a good and fine understanding about this problem, because it is designed in such a way, right? ठीक है, दूसरा is else case है, and then you have to do such things since you have to do sum minus minus, and you have to uh, reduce the number of possible sub arrays using using from the map which you have stored for previous iterations, right? ठीक है, and whenever you are updating your sum, you have to push it, right? Because for that particular sum you found another sub array, so you have to, if the sum is present in your map, well and good, just do plus 1. If not, then initialize it 1, and that's the function in Java. You can see map.getOutDefault. And at last, since you need to find the all possible sub arrays, right? That's how this 12 was getting. For this x, for this third row representing x, we sum all the number of entries, right? So that is why for each after each and every for each iteration in a for loop, we are doing answer equals answer plus 1, then that's we are returning answer. But however, this code gets compiled but gives you the TLE, right? So this code has already been coded in O of n, but still it is giving TLE. So I think there is a Java limitation there, right? The things which are writing for map and all, I think that's the limitation of Java. Instead, in the editorial section, you can see that they have used the uh, uh, 1D array for 2 cross n plus 1, right? They are doing the same things, but then they are doing an array, and it is getting accepted. But that is not the problem with C++. If I run the C++ code here, it will definitely get submitted, because it is somewhat always faster than Java regarding the complex coding problems, right? So that's the same exact code present in C++ and have the same complexity of O of n, and O of n as a time complexity. So but this code will get submitted because of the maybe the limitations advantage on the language specific things, and I guess that's the reason the competitive coding is more famous using C++. So that's all for this video. Sorry for the delay, And the last thing I would like to repeat again, that if you do not do the dry run of this question in, let's say, 1 or 2 test cases, you will not able to get a fine understanding about it. So this problem is more about understanding than solving. Let us meet in the tomorrow's POTD, which is of day 150. I guess this problem, distinct difference, I'll solve this one and then upload, right? So till then, take care, bye bye, keep learning and keep going, bye bye.